Hi everyone, it is Việt again. So we finished problem 5 and now we will go work with another problem. Let's pick number 25. So we need to use the Lagrange multiplier to find the minimum distance from the curve to the indicated point. In this case, it is the parabola y equal x squared plus 1 and the point 1 over 2 and 1. So at normal, I have it here. The parabola y equal x squared plus 1 and the point 1 over 2 1. So first let's use the applet to represent the curve and the point. So here is the applet. First of all, let me clear the graph and I will represent the curve. The problem gives us y equal x squared plus 1, so let it equal t. So y gonna equal t squared plus 1. D gonna equal 0. So let's grab it. And let's change the point to xy point. Now let's add a point. The point is 1 over 2, so it's gonna be 0.5, 1 and 0. Okay, let's make the curve primary color. So here is the curve and the point that we have, and I already put it here. If we call the point on the curve equal, let's make it equal. Let's make it here. So we need to find the Q point on the curve, so that PQ mean. So let's write down. Let Q coordinate xy be a point on the parabola. Then the and P 0.5 1 is the given point. Then the distance PQ is given by PQ square equal 8.5 square plus y minus 1 square. Let's call it the function fxy. And let's look at the parabola again. Y equal x squared plus 1, or we can write it as x squared minus y plus 1 equal 0, and we will call it g equal. One more thing is the problem asks us to find the minimum. It means we need to find PQ mean. PQ mean if and only if PQ square mean, because PQ larger than 0 or equal 0 in the case that P in the curve. So it gives us, so we need to find the minimum of fxy given the constraint g equal. Okay, so it's gonna become very similar to the problem number 5 that we did before. First thing, we need to find the gradient of fxy. G of fxy equal, let's see, equal to 2x minus 0.5 I plus 2 times y minus 1 j equal 2x minus 1 I plus 2y minus 2j. Let's find the gradient of gxy. Gxy equal 2x I minus j. Then we will j. Okay, so let's see, using Lagrange multiplier equation, we have g of fxy equal lambda times g of gxy if and only if 2x minus 1 equal 2x lambda, let's make it 1, and 2y minus 2 equal minus lambda. At this point, you can do like problem 5, finding the relation between x and y and replace that to the constraint way. However, it will be complicated if you do that. This one, I suggest you using the given constraint equation, gxy y equal x squared plus 1, and put 3. From 2 and 3, you will have 2 times x squared plus 1 minus 2 equal minus lambda. It means 2x squared equal minus lambda. So let's make this one to 4. Let's make some arrangement to 1. So we have 2x minus 1 equal 2x lambda. It means 2x times 1 minus lambda equal 1. Let's call that 5. Replace 4 into 5. We have 2x times 1 plus 2x squared equal 1. So 2x, let's make 4x cubed plus 2x minus 1 equal 0. Using calculator to solve the above equation, we have, let's do that. So let's go to equation. It is the 3-degree equation. So the Q for B is 0, we C is gonna be 2, and D is gonna be minus 1. So we have 3 x. However, you can see x2 and x3 it is the complete answer. So we only worry about the first one. It is gonna be 0.38546. 0.38546. So y gonna be equal x squared plus 1 gonna be equal, let's do that, 0.38546 square plus 1 equal 1.14858. 1.14858. So from that we have x and y value. Now we will replace the value into to find the PQ distance using the formula, the distance formula above. So we have PQ square gonna equal x minus 0.5 square plus y minus 1 square gonna be equal 0.38546 minus 0.5 square plus 1.14858 minus 1 square. I will not give the answer, so let's write that in the calculator. It's gonna be 0.38546 minus 0.5 square plus 1.14858 minus 1 square. It's gonna be 0.035195. 0.035195. So the PQ gonna be square root of PQ square, and it's gonna be 0.188. And it is the answer that we need to find. So let's say thus the minimum distance from point P 1 to the curve to the parabola y equal x square plus 1 is 0.188 units distance. So that's it. We're done with the problem. It is the correct answer. I check it on the back of the book, and the hint I give you here, be careful when you replace x and y. If you look on the equation here, when I replace 4 and 5, I put here 4 is the minus lambda. When I replace onto 5, minus lambda disappear, so the sign change to plus. When I shown it before, I forget to change the sign, and I totally get the wrong answer, and it takes me a lot of time to figure out. And another way like I tell you about, if you don't use the constraint equation here to substitute into 1 and 2, you can still do that, but it's more complex. So there, and so I want you to remember, it is the system of 3 equations, 1, 2, and 3. In a lot of time you can solve 1 and 2 and replace that to 3, but at the time you need to use own 3 equations to solve it. So that's it. I will see you in the next problem.